Good morning, Munandor present here. This is Sarala going to give a presentation on routing in the unit 3 of data communication and networks. Before entering into the topic routing, now let us see what are the objectives of this data communication and network. So the first objective of the data communication and network to understand the division of the network function into the layers and be familiar with the components required to build different types of network. And third one will be to categorize various unicast and multicast protocol and their functionality. And the fourth one will be to learn the flow control and the congestion algorithm. And the last one to illustrate the various service offered by the application layer. And now let us see the course outcome. On the successful completion of this course, the student will be able to, the first objective will be to identify the components required to build different types of network, and second one to choose the required functionality at each layer, and third one to identify the solution for each functionality at each layers, and fourth one to trace the flow of the information from one node to another node in the networks, and fifth one to understand and differentiate the various unicast and multicast protocols for the routing data, and sixth one to code the various utilities of the application layer and identify their function. Now let us enter into the topic routing. So you all know, routing is one of the important function which is performed by the network layer. So it is used to define how to pass a packet from the sender to the destination, so which is nothing but the input interface to the output interface of the network. So it will tells how the packet will be routed and what how to find and set up a route. So this packet will be routed with the help of the routing table, and the routing table will be of two types. One is called a static routing table, another one is a dynamic routing table. So static routing table, whenever the information contained in the routing table or information present in the routing table or manually updated, that is called as the static routing table. And another one is a dynamic routing table, whenever the information in the routing table is done by the software within the. So next one, so routing can be done within the domain or between the domain. So that is called as the inter-domain routing protocol and inter-domain routing protocol. So intra-domain routing protocol is nothing but the routing whenever we route the packet within autonomous system, that is called as the intra-domain routing system. So inter-domain, whenever we are going to route between one domain to another domain, it is called as the inter-domain. So the intra-domain ignores the internet outside the AS, whereas in the inter-domain it assumes that the internet consists of the collection of the interconnected autonomous system. So what are the protocol we are going to use in the intra-domain, which is nothing but the interior gateway protocol or IGP protocol. So popular protocol used in intra-domain are RIP protocol and OSP protocol. So whereas the protocol used in the inter-domain is nothing but the exterior gateway protocol or EGP or BGP protocol. So next one is a component of the routing table. So component of the routing table is nothing but the procedure for sending and receiving the reachability information about the network to the other network is called as components. That is called as the components of the. Uh, so how to approach the shortest path? Okay. So there are many algorithms. There are two basic routing algorithm to find the shortest path. One is called as a distance vector routing algorithm. Another one is the link state routing algorithm. In the distance routing algorithm, in the distance vector routing algorithm, each node knows the distance to its directly connected neighbors. Uh, a node, when it sends periodically a list of the routing updates to the neighbors, and if all the nodes update the distance, the routing table eventually coverage. So the new node advertise themselves to the neighbor node. So that's about the distance vector routing algorithm. In the link state routing algorithm, each node knows the distance to its neighbor, and the distance information, that is a link state, is broadcasted to all nodes in the network. Each node calculates the routing table independently. So now let us see the distance between the distance vector and the link state. So routing information, distance vector uses the protocol which is called as RIP protocol, whereas the link state vector uses the protocol which is called as the OSPF protocol. So open shortest path protocol. So you, for example, you can have a router. So you can consider any number of routers in a network. For example, four routers means the network. We have to find out which network it is present and via which network it has to be transmitted. What is the metric, that is a cost metric to be transmitted. So how the routing is done in the distance vector, it is nothing but with the parameters like periodic updates, triggering updates. So the periodic updates is nothing but updating the routing table or sent at the end of each certain time period. So it can be typically 90 seconds. Triggering update is nothing but if a metric change on the link, a router immediately sends out on the update without waiting for the end of the periodic update. So it can be full routing table update or router invalidate timers. So most of the distance routing vector protocol send their neighbors the entire routing table, not only the entries which just changes. So the routing invalidation timers is nothing but the routing table entries are valid if they are not refreshed. A typical value is to validate an entry if no updates is received after 3 to 6 update period. So what are the problems involved in distance vector, and why we are going for distance vector? It is nothing but the count to infinite problem. So suppose one node is broken without knowing that the packet will be transmitted. For example, if you consider a three router A, router B, and router C. So the router A, suppose C node wants to transmit the packet to via B. So the same thing, now the links, now let us consider that the links between B and C gone down. So what happens, the packet will be forwarded to C, and again C does not know that the link has gone down between B and C, so it will be going on forwarding the packet to that one. So instead of reaching the destination, that a packet will be going on between the nodes. So that is called as a count to infinite problem. Thank you.